Hello, this is Susan Poss again. I'm still working in section 9.6. This is my third video, 9.6.3. And we're looking now not at parabolas and lines and absolute values and ellipses, but we're actually going to look at the graph of a radical function, since this chapter is all about working with radicals. So we have a function here named f. We read that f of x. X is the argument. And then what this is equal to is the square root of 2x plus 3. Now I know it's a square root because there's nothing written here in this index spot. And when there's nothing written there, you understand it to be a square root. Okay, so when you're taking the square root of something, you can take the square root of positive 4 because positive 2 times positive 2 is positive 4. But you can't take the square root of negative 4 in the set of real numbers because in order to come up with a negative result, one of these multipliers needs to be a positive 2 and the other one needs to be a negative 2. In order for it to be a square root, it has to be the same multiplier to give you that negative 4. So when we move on into the next section, you're going to be given something called an imaginary number. It's going to contain a little lowercase I. But for now, we're working only in the set of real numbers. So this 2x plus 3 radicand has to be something greater than 0 or equal to 0. So it has to be positive. That's what greater than 0 means, positive. Or it can be equal to 0. Now, if you've forgotten how to solve inequalities, again, you can go back to the playlist in Math 101 on my same site and look at how to solve inequalities. All right, so this identifies the domain for me. This tells me that the x values must be greater than or equal to negative 3/2. So that's going to be the low end. And then I already know this is going to go out to infinity. So let me work a little bit and explain why I know that. So I've taken, let me get the function written down again here. I've selected some numbers here. I started with that negative 3/2. And I hope you can see that this gives us a negative 3 plus 3 under the radical. So we're taking the square root of 0, which is 0. So that's my first point, negative 3/2, comma 0. Okay, so the next point, let me change color so you can see when we go from one to another. The next x value I chose was 0. So we're just plotting points here. And this is where you're going to need your calculator to get an approximate value for the square root of 3. So 0, 1.73 is right about there. And you just kind of estimate these things. The next value I chose was 1/2. And you'll see why I chose that. Now, half of 2 is 1. 1 plus 3 is 4. And the square root of 4 is 2. So 1/2, 2 is right about there. And then the last one that I picked was 3. And again, you'll see why I chose these numbers. I was trying to avoid having to use my calculator a whole lot. So I was shooting for things that would be easy to take the square root of. All right, so you're going to learn that these square root functions have sort of a characteristic shape Just like an ellipse has a particular shape and a parabola has a particular shape, when you're working with a square root function, it also has a particular shape. So you can see there that domain that I defined earlier. It begins here at negative 1.5 and it goes out to positive infinity. Right, what about the range? So the range never dips below that 0 line, and it's starting here at the 0 line, and I hope you can see or think about, if we extended this, not only would it go further and further out to the right, it would also climb higher and higher up towards the top of the grid. So this range starts and includes 0. You can see it includes 0 right there on the chart, and it goes out the top of the picture to positive infinity. All right, that's a good place to stop with that one. Let me see if I can get all this in here. There we go.